Hello friends, good evening. Welcome back to Domain Analytics program by 360DigiTMG. So we are looking into oil and so we are looking into oil and gas data analytics. Okay. Oil and gas data analytics. So in case of oil and gas data analytics, so we have looked into different applications. On the day one, we have looked into different applications of oil and gas analytics. So here we are dealing with the data that we are getting from oil and gas industries. So what do we have here? So we can divide data based on marketing and economics. In the same way, we are going to get data from drilling process. So in the same way, we can get data from manpower, people who are working in these oil and gas reservoirs, logistics, and most of the data we'll be getting from different sensors, the IoT sensors that they are going to use in oil and gas data analytics. So today we are going to look into unsupervised learning. So what is unsupervised learning? So in case of unsupervised learning, if I have a data and the data is structured data, okay, I am taking a structured data, I am going to consider this data as a single entity. That means in this data, I have only input variables. I do not have any output variables. So this data is known as unlabeled data because we do not have any label, or we call it as output, or we call it as target. Okay, this variable will be missing. Okay, this will not be available in case of unsupervised learning. So how to deal with data? This is data. So we have to look into this data and we have to find the hidden patterns in this data. Based on these hidden patterns, we have to work on this data. So that is nothing but unsupervised. So in unsupervised learning, one method that we have is clustering. Clustering is also known as segmentation. That means we are going to divide this data based on similarities. So based on the similarities between these different records that I have here, based on the similarities, I am going to cluster this data. Different clusters will be formed. So maybe, okay, if I take this data, I am going to create different clusters, and based on the clusters, I am going to label this data because it is an unlabeled data. Now I am trying to label this data. Yes. So what is happening here? I am trying to reduce the variation in the data. How? So the data that I am getting here, that is based on the similarity factor. So most of the values that are similar, okay, most of the data points that are similar, I am trying to combine them. So if I have some data, okay, this is my scatter plot. So if this is my scatter plot, I have two different clusters. So we can see here. If I say that this is one cluster and this is another cluster. So these clusters are formed based on the similarities. So if I take it this way, okay, so here we can see that all blue data points in one cluster and all yellow data points in one cluster. So here the similarity is the color. Okay, for simple understanding, here the similarity is color. So based on the similarity, we are trying to we are trying to divide this into different clusters. Okay. Now I am going to label them. So what will be labeled here? Yellow data points, blue data points, right? So some meaningful clustering I am doing. So this is nothing but unsupervised learning. So in case of unsupervised learning and clustering, in when we take clustering method, in case of clustering, I have two different methods. Okay, hierarchical, okay, hierarchical clustering, and K means clustering. In case of hierarchical clustering, again I have two different methods. One is agglomerative clustering and the other is divisive clustering. So it's like we are going to have the data. So different data points I'm going to have, and I'm going to cluster these data points based on the distance between these data points. So we have different methods that we consider here to find the distances, and based on these distances, I am going to finally. So I am going to have some data points here. From these data points, I am going to combine. Okay, I am going to combine some data points and I am going to have some clusters here. Again, these clusters ultimately combine to form a single cluster, a large cluster. So that is what happens in hierarchy. So here we have something called as dendrogram. So we have a graphical representation that we have here that is known as dendrogram. Okay. So based on dendrogram, we can see the number of clusters here. Okay, to visualize the number of clusters, we have here that is we have a representation that is known as dendrogram. So what I'm going to do, I am going to cut this particular representation, what I have. Based on this, I am going to decide number of clusters. Here in this particular representation, what I'm showing you, we have two clusters. Based on these two clusters, I am going to apply the agglomerative clustering and I am going to get my data. So I'm going to divide my data into two different clusters. So here we are not deciding the number of clusters. Okay, so based on the analysis, we are going to get the dendrogram, and based on the dendrogram, by looking at the dendrogram, we are going to decide the number of clusters. So that is one method. But the problem is, it doesn't work for high level data. If we have high volume data, high radical clustering will not work. So that is one thing we have to remember. So in the same way, we are going to use k-means clustering, where k is nothing but number of clusters. So we are dealing with number of clusters. In case of mean, so we are going to get the clusters. Okay, we are going to take the distances. We are going to take the mean value. Based on that mean value, we are going to consider all this. We are going to fix the number of clusters at the end. Okay, so the total number of clusters. So initially we have to come up with the number of clusters. If it is 2 or 3 or 4. Okay. So that is the difference between hierarchical clustering and k-means clustering. So let us see what do we have in k-means clustering in detail, and how do we use k-means clustering in oil and gas data. So basically, we can work on different techniques. So when it comes to clustering technique, in case of oil and gas reservoirs, so we do reservoir characterization. Okay, so we use clustering techniques here. We use clustering techniques that begins with the assignment of number of clusters to be formed. So why we are using this? So the points that will represent the centroids of these clusters. So based on the centroids, we are going to decide the number of clusters. So Before that, what we have to do here, we have to work on CRISP MLQ. Okay, this is the project management methodology before we start our project. Okay, so here we are dealing with some data that is related to oil and gas data analytics. So it is related to oil and gas industry. So what we have to do, we have to understand the business and data understanding. Understanding business and data understanding, that is very important. Okay. So data preparation step, that is the second phase that we have. And after data preparation, we have to get into model building and tuning, then model evaluation, deployment, and monitoring and maintenance. These are 6 different steps, different phases that are very important. So these are very important. So what happens here? Okay, so this is a cyclic process where first we have to understand the business. Okay, why we are doing this analysis, what is the problem statement that we have to record our objectives, and we have to record our all these details. Okay, record the high level information that we have to record that into our project chart. Then we understand our data. So what are the different data types? So where we have all the data. Okay. So this information is very important. Then we go for data preparation. Then if everything is okay, model building, and we work on evaluation. If there is any issue with evaluation, so we have done tuning and everything. Okay, we have worked on our data, but it is not working. We have to go back to business understanding step. So these are different phases that we have. So these are very important when we deal with any supervised or unsupervised model. So when it comes to unsupervised learning, so when it comes to unsupervised learning, what is unsupervised learning? That we have to understand. So when it comes to unsupervised learning, it is a machine learning technique. Okay, unsupervised learning is a machine learning technique in which models are not supervised using a training data set. Okay, so we do not have any output variable, so we do not directly train the model. Okay, so there is something that is very important. So we don't have the training. Okay, we do not supervise the model with training data. So we have only one data set, and on that data set we are going to do our analysis. So instead, the models themselves find the hidden patterns, right? As we divide the different clusters and all, and insights from the given data. So it can be compared to learning which takes place in the human brain, right? Immediately when we see something, we try to analyze that data. So in the same way, we have only data. We do not have any output, but seeing the data, we try to recognize the hidden patterns and insights in my data. So this is something important. And when it comes to the goal of unsupervised learning is to find underlying structure of the data set. So group the data set accordingly with the similarities, and it will be represented in the data set separately. Okay, all these clusters will can be separated, and they can be labeled. Okay, so that is the main goal of unsupervised learning. Okay, so it could be clustering or anything. It could be subclustering or anything. We are trying to group the data according to the similarities. So the resultant groups or clusters will have low variance. This is very important to understand. Okay, because all the data that we are taking into different cluster, what it will have low variance here. Okay, these are similar products, only similar products that we are trying to take into consideration here. So in the same way, so we can observe clearly what is happening. Okay, in case of unsupervised learning, here we can see if I have some data. This is say something input raw data that we have, where I have some images of cats and dogs, unlabeled data. Just I have a folder where I have all these images. Now I have to use an algorithm based on the similarities. Okay, there will be some similarities between these two, right? Because these two are dog images. Okay, in the same way, we have some similarities between these two. So based on these similarities, we have to process. Okay, we have to process and we have to classify these images. Now I have two different classes here. One we see it as dogs and the other is cats, right? So this is a simple explanation that we have that is related to k-means clustering. So just unsupervised learning, okay, based on the similarities, we are trying to classify this. So we have different unsupervised learning algorithms that we have, such as k-means clustering, k-nearest neighbor, hierarchical clustering, anomaly detection. We have neural networks, principal component analysis, independent component analysis, a priori algorithm, singular value decomposition. So where in case of popular principal component analysis and singular value decomposition, these come under dimension reduction. So this we have already seen, right? So this is the flow chart that we have, where we are trying to show we will be having the historical data. We apply this, we feed this historical data on machine learning model, and we are going to find the hidden patterns. Okay. So maybe these hidden patterns could be applied on a new data, and we can get the prediction. We do not have a particular training. We are not training the data. We are not training and testing the data. We are directly trying to find the rules and patterns in the data. So now we try to understand what is clustering is. So in this image, we can see the image that is on the left side here. Okay, this is nothing but unlabeled data. I have some data. We don't know what is this data is. Now on the right side, after applying k-means, I can see that there are three different clusters here. Okay, based on the color, I am recognizing this based on the color. The similar color data points are being clustered, and here we can see the X. That is nothing but the centroid. Centroid is the center point. Okay, center point of this cluster. Okay. So this is nothing but the k-means cluster. Okay, let us see how can we apply k-means cluster. So what are the different steps we have here? So in k-means clustering, it is a unsupervised learning method that aims to group similar data points. Okay, so here the factor that we are considering is similarity. How do you find the similarity here? Okay, so it allows us to cluster the data into different groups, and a convenient way to discover the categories of groups. Okay, so we can use, okay, if you have a unlabeled data and we are trying to find the categories of the groups without the need of any training. Okay, directly we are doing it. Okay, we are just applying my machine learning model, and I am getting three different clusters. That's it. I have the data. I am dividing this data into three different clusters. So this algorithm that we are discussing here, it is a centroid based algorithm where each cluster is associated with a centroid, as we have seen earlier. So every cluster will be associated with a centroid. And the main aim of this algorithm is to minimize the sum of distances between the data point and their corresponding clusters. That means, let me, if I have data in this way, now I have some data points here. So these are some data points. If I'm saying that these three are different clusters, these three are different clusters, and I have a centroid in between. So always I will be having a centroid in between. Now I will be trying to find the distance between centroid and each and every point in each cluster. Okay, cluster one, cluster two, cluster three. These are three different clusters I have. If the distance between each data point and this particular centroid is less, okay, I am going to find the sum of distances. That means I am going to calculate all the distances and I am going to get a I am going to sum all these distances and I am going to get some x value. Okay, I am going to get some y value here, z value. I am looking into the minimize. Okay, minimum. So the centroid should be in such a way, right? That cluster should that cluster should give me the minimum value of sum of distances. That is very good. So if I am saying the distance between the centroid and the cluster and the data points is less, that means the cluster is very intact. Okay, very similar value we have. Okay, so in the same way we will be trying to find the distance between the different centroids also. And here we should have the higher value. Okay, the distance should be more. Okay, these are the two different factors that we are going to consider when it comes to K-means cluster. So there are different steps here for K-means clustering. So the first step is we have to initialize the K value. That means I have to decide how many number of clusters I need. So I said two. So if I say I need two clusters, that is the minimum number because below that we cannot do. Okay. So it should be greater than one value. Okay. It should be greater than one value. So what I have given here, I have given two. So for each sample in the set of samples, assign sample to its closest cluster based on the Euclidean distance. So what we have to do here, if I have a cluster, okay, if there are, okay, if there is some data here, I have some data here. What happens here? Randomly based on the centroid, okay, based on the number of clusters and based on the centroids, okay, we have, okay, it randomly selects two different clusters, okay, two different clusters, and as we have two different clusters, two different centroids will be initialized. Okay, so now we are going to try the distance between each and every data point and the clusters we have. And the distance measure that we are going to take here is known as Euclidean distance. Okay, each and every column. In the same way, I am going to measure the distance between this data point and each and every data. Right? So what we are going to get the distances. Based on the distances, which particular data point is near to this set, right? And which data points are near to this set. That will be formed into two different clusters. Now, the now the process doesn't stop here. Okay, what happens in the next step? For each cluster in the set of clusters, we are going to recalculate the cluster set, right, based on the mean of the samples. So we are going to add, okay, we are going to add all the data point values and we are going to take the mean value. Based on the mean value, I am going to get two different centroids again. So I am going to take that centroids and again the step 2 and 3 will be repeated until I get the criterion. Okay, the stopping criterion is fulfilled. That means at some point, my mean value will not change. It remains same. So until that, we have to continue the process. And the step 5, determine the variance of each cluster and SSC. Okay, and repeat the steps 1 to 5 with different initialization of cluster centered positions. Okay, because every time these centered points that we are taking initially, these are random values. randomly these will be selected from the data. So every time we start the program, every time these random values will be changed. So what are the different advantages of k-means clustering? So in case of k-means clustering, k-means clustering algorithm is used to group unlabeled data. If I have an unlabeled data set, I am going to group this unlabeled data set. Okay, and we have, when it comes to k-means, it is the most used clustering method, largely due to being computationally inexpensive. Okay, that is one factor we have to consider, and it can scale well with large data points. Okay, and it is an appropriate method when you know the number of clusters. Okay, how do you get these clusters? It is based on the data. It is based on the data and the business knowledge, based on your maybe your stakeholders. Okay, business stakeholders who gave this project, he may ask you to give me 3 clusters. Okay, you are going to work on 3 clusters. Okay, but based on the complete analysis, you can also suggest, you can experiment on this number of clusters, and you can suggest that maybe you have to take 4 clusters, then you can get the better results. That we can do, and it is speed. Okay, so what are the limitations here? Okay, when it comes to k-means clustering, what are the different limitations we have? So number of clusters must be chosen upfront. We don't know how many number of clusters, so we have to choose these number of clusters upfront. And outliers can have a strong influence on results. If there are any outliers, they may have strong influence on my k-means clustering. And we have to initialize the centroid positions, have a strong influence on result. Okay, initially randomly we are doing it. So maybe by changing these centroids, there may be change in the data. Okay, maybe other output. So it does not cluster well with clusters of varying sizes and density. So that is one limitation that we have with k-means cluster. So like for initialization, we have got some different algorithms like k-mean plus plus. Okay, for ran, okay, we are taking the centroid values. For taking the centroid values, now we are using mean method. Okay, k-mean. In the same way, we have k-median, we have k-medioid, okay, k-mode. Okay, there are several methods that are there. Okay, apart from mean, we can also take all these methods for k-means clustering. Okay, for clustering. So what are the key concepts that we have in case of k-means clustering that we have to understand? So sometimes what happens, if I have some data here, so these are 2 clusters here. Okay, I have some data here, but there will be some data point that is in between that will be oscillating between these 2 clusters. So I cannot get any result from this. So it will be keeps on oscillating, and the process will be continuously going on. So every time we get clusters, what we are doing, again we are calculating the mean. Based on that, again we are getting 2 different centroid values, and again we are going to continue this process until I get some point where I am going to have the same mean value. So there will be some convergence criteria here. Okay, when the convergent point comes, so there we are going to apply it. But in this case, to avoid this oscillation, okay, to avoid this oscillation, what we have to do, we have to specify the number of iterations, like 100 iterations. So if it is completing before 100 iterations, that is fine. So if the process is going through all these iterations, at that point, automatically it stops the process. So that is one thing we have. And when it comes to convergence criteria, it is to stop when a cluster centroid moves less than a certain percentage of smallest distance between any of the centers. Like at some point, we are going to get the almost same median, and it is not moving forward. Okay, so the centroid is fixed at some point. The cluster, the centroid is not moving anymore. Okay, then we compare between the cluster variation to within cluster variation, between cluster variation and within cluster variation. That means when I'm saying within cluster variation, we are going to measure the distance between the centroid point and the data points. So that should be low. When it comes to between cluster variation, the distance between the centroid point of the cluster of cluster 1 and centroid point of cluster 2. I am going to measure the distance between these measures, these different clusters. Now what I have to get, this distance should be more. Okay. Then I am getting the best clusters, right? So that is something we have. These are few points, these are key concepts that you have to remember when it comes to K-means cluster. So now we try to understand the use case here that is related to uh, oil and gas analytics. Okay. So what I'm trying to do here, I am trying to work on segmentation of different oil companies' share prices based on oil price fluctuations using K-means clustering. So what do we have here? The data I have here that is related to oil companies, and this is something related to share prices. And based on the, and we have oil price data also. What will happen here? As there might be a lot of fluctuations in the data. Okay, when I have more oil price, maybe my share price might be increasing. When my oil price comes down, maybe my share price is coming down. That we don't know. Okay, so we are taking different oil companies' data, and we have taken some time lapse here. We have taken some data from different years. Okay, from 2000 to 2017. Okay, then we are trying to work on this data. So what do we have here? What are the different attributes I have here? Date, share price, oil price, year, name. These are the different attributes I have. And we have used the Python libraries such as Pandas, NumPy, and Matplotlib. And for the machine learning side of project, we have used the sklearn and k-means modules. And we can see the data. I have date here, which is in sequential order, I can say. We have share price, oil price, year, name, and we have scaled the share price data. Okay, we have done some scaling. And here we have taken the EDA part. Okay, when it comes to EDA, what we have done here? So we have taken the date. That means the data has been taken from 1988 to 2024. So what is happening with the fluctuations here? Okay, so we have taken the oil prices here, and we can see that in 2008, in the period of 2008, there is a high oil price here. So the oil price is high in this area that we can see. In the same way, and suddenly this value came down in this period. Okay, that is something like 2009 and 2010. The value came from which went to 140. It came up to almost $30 a barrel. Okay, we are speaking about the barrel price here. In the same way, at some period in 2020. Okay, after 2020, when we have the COVID crisis, we can see that the oil price came below $20. Right? Again, now based on the recent data, we can see that it came up to around $120. Okay, now it is going up. So in the same way, I have tried to compare the share prices also. Okay, when we have looked into share prices, okay, share price and oil price. Okay, we can see that there is a lot of fluctuation here. based on the years. Okay, here we have taken the years, and these dark colors are showing me the 2017. And as the gradient is moving up, we can see that from 2000 to 2017, the color is becoming darker. So these regions, what we are seeing here, okay, these regions, what we are seeing, these are some data that is related, that is from, this is some recent data. Okay, this data is something from 2014 to 2017. Okay, so we can see the fluctuation here. Okay, what is happening here? Okay, here we can see the share price was around 200. Okay, in this period. Okay, this period something like in this period that we are seeing from 2000 to 2004. Okay, the value is very less, but nowadays, okay, nowadays in this period, if you check the data, what we can see here, it is somewhere around $500. Okay, it went up. Okay, it went up and it is around $500. So these things we can notice when we are working on our EDA. So here we have taken how to decide the number of clusters, right? So there is one factor that we need to consider. So here we have taken something called as elbow curve. Okay, so here we have taken something called as elbow curve. This is called as elbow curve, okay, or scree plot. Elbow curve or scree plot. Okay, x-axis, okay, x-axis will have the inertia value. That means we are going to take the total within sum of square values here. Based on that we are going to calculate, and in the x-axis I have the clusters, number of clusters. I have taken from 2 to 14 clusters, and I am going to look into the data. So here I have got some value that is around 6, where there is a sudden change we can notice. Okay, you can see some change of values here. Okay, so this data, okay, this data we are going to consider, and we are going to take the number of clusters here. So these are the final clusters that we have got. Okay, we have taken the oil price and share price, and I have got 6 different clusters here. Okay, so we can see here, we can if we notice this data. Okay, when I have my uh, share price. Okay, when you can see here, when I have my oil price 40, what are the okay? So what is happening in this company? Okay, in this company, the share price is somewhere here, right? The share price, we can see these 3 clusters representing the share price. Okay, along with these clusters, we can see here this cluster. Okay, this cluster in brown color. Okay, this cluster in brown color, you can see that the price is almost up to 0.6. This region. Okay, so the oil price was low, and we can see the share price was also low here. Okay, but these clusters we can see here, the oil price is high, but also we can see that the share price is moderate. We have the oil price as something like $120, okay, per barrel, and I can see the share price is 0.7. Okay, where do you have the highest share price? That we can see in this particular cluster. Okay, that is cluster number 2. Okay, I can name the clusters here. This is okay. This is the cluster number 2 here, and this is 1, and this is 0, and we have 3, 5, and 4. Okay, so cluster 2, I can notice that the share price is very high, and the oil price is also very low. Okay, so we can analyze more. Okay, by using this data, we can analyze more. Why? What is the reason? Why the share price has increased? There might be many factors that might be influencing this. Okay, so all these aspects are very important. Maybe there may be some war is going on. Okay, all these external factors also play a major role when it comes to oil prices. So let us see the same thing. Okay, same thing in program. Okay, let us look into the program what we have done. Let me increase this here. Okay. So the same program that we are seeing here. Okay, the segmentation of different oil companies. Okay, share prices that we are doing based on oil prices. Okay, how the values are fluctuating, how these both values are fluctuating. Okay, when compared to each other. Okay, so we are trying to look into this data. So what do we have here? First, I am trying to load this data. Okay, so I have to import all these different. Okay, all these different. Package that we have. Okay, I have imported matplotlib. Okay, I want to plot some graphical representations. NumPy, pandas, Seaborn. Seaborn is also used for graphical representations. So I have imported all these different. So the data that I have taken from a XLR file. Okay, to install that, it's a very old format. To install that, what I have done, I have to update few packages. Okay, I have to update few packages that I have done. So I have updated these packages. Based on that, I have got this. So after updating, now I have taken the data. So I have different data sets here. Okay, when we look into the data here, we can upload the data. Okay. Let me upload the data here. Okay, so here I have all the files. Okay, so I am going to select all the files and open. So we can see here, there are number of files from different companies. Okay. So one file here, okay, one file here that we can see that represents the oil prices here. Okay, remaining all files that are related to different companies. So we can look into the data. Okay, once yeah. Okay. So first we have taken data that contains the date and oil price. Okay, first we are taking the date and oil price. Okay, this is my data, what I have, and I have taken the date and oil price here. So now, in this line of code, I have named this as shares. Now, what I am doing here, I am taking all these files, okay, all these files that contain the data that is related to share price. Now, what I'm going to do, I am going to map the share price, oil price with my date. Okay, so date will be constant. Date will be constant. Using date, okay, as constant, I am going to map all these values into one. So I am going to map all these values into one data frame. Okay. So I am naming that as all data. Okay. So I have taken few values. Okay, I have taken few values, and based on the values, I am going to do this conversion. Okay, these all comes under data pre-processing here. So when I look into the final data here, okay, so I have date, I have share price, I have oil price here, year, name, okay, and share price scale. From where we have got this. So here we have used min max scaler. Okay, we have used min max scaler. Based on the min max scaler, I have converted, okay, the same data, okay, the share price data. I have used this share price data. I have scaled this data. Okay, I have used min max scaler. So now I have the data. I have saved the data. Okay, I have given the variable name that is stock here. Okay, I have saved the complete data here. Okay, this will be my output data. So I am going to look into these values: date, share price, and oil price. Now I am going to make some clusters based on this data, and I will have the different companies. So I'm going to start the Data analysis. Okay, how I am going to do that? So I have used simple line plot. Okay, I have used some line plot here. Okay, using line plot, I have worked on the oil price. The same way I have used pair plot. Okay, from 2000 to 2017 here. Okay, so I have used a different color gradient to represent it. I have taken the data, okay, only one company, and I have worked on. Okay, here we can see the pair plot on BP. Okay, this is the company name. Okay, in the same way, while plot I have taken, okay, different plots I have taken for my EDA processing. So we can see here what is happening with the oil prices. Okay, so at some point in 2008, we can see there is a high value for the oil pricing, but it suddenly came down in around between 2009 and 2010. Okay, it suddenly came to $30 or something. Okay, and we can see recently somewhere around 2017, it came below $30. So in the same way, I have taken the line plot where we can see the share prices. Okay, we can see the increase of share prices, and I can see the high share price around 2017. Okay, where the share price went up to 80. So I have compared, okay, I have tried to compare these two values, okay, share price and oil price for different companies. You can see this analysis for different companies. Okay, I have taken all these companies and I have tried to compare these values. Okay, so I have tried to find the correlation between these values. So that is the analysis what we have here. And in the same way, we have used the joint plot where I have got the line plot as well as so different plot I have taken here, oil and share price. So here I have taken only few years. Okay, what is happening to the end? Okay, if I have data from 2000 to 2017, I am trying to look into this particular data here. Okay, so here I have taken these values for all these data. Okay, all these data, each and every company. Okay, so I am doing EDA part for each and every company, and I am looking into the data. So how my data is dispersed. Okay, so here I am looking into the share price. Okay, share price of each company, what is happening here. Okay, so how these values are distributed? Okay, is it a normal distribution or what is happening here? Okay, that is very important. In case of PMO, okay, in case of PMO, I can see some normal distribution here. Remaining all we cannot able to predict much, but in case of this particular data, okay, PMO is the company where I can see that there is some correlation here. Okay, and it is positive correlation. Okay, I can say that it is strong positive correlation, I can say here. So that we can find out from these values. Okay, the same. Okay, the same I have tried to look more. Okay, because here I couldn't find because of color gradient. Okay, now I have taken the color gradient, and now again I am trying to check these values. Okay, so here I have taken the years. Okay, in which year? Okay, based on the color gradient, I have taken the years also. What is happening when compared to? So now I have tried to use to do the clustering here. Okay, I can use the both supervised learning and unsupervised learning methods, but I have started with unsupervised learning. Okay, so I have used the k-means clustering here. So using k-means clustering, I have done the clusters. Okay, so I have divided this into 6 different clusters. Okay, so I have applied the same thing on all companies, all company data, and I have divided the clusters. So I have done the clustering process here. Okay, based on the oil price and share price, I want to see the relation. Okay, correlation. I have correlated these both, and based on that, I have constructed different clusters here. Based on this, we can find, okay, what is happening if share oil price is increasing, whether the share price is increasing, or is there anything. Okay, so that we can find out. So we can notice, okay, how we have taken this. Okay, I have used, okay, the scree plot here. Based on the scree plot, I have selected 6 clusters, right? So we can see I have selected 6 clusters. So these are the different clusters that we have seen, right? So this is the clustering. Okay, this is the k-means clustering that we have performed on the share price and oil price. So same thing. Okay, same thing. We can also do. Okay, we can also perform the supervised learning. Okay, here we can see the linear regression. Right? I have used the linear regression, and based on that, I have got some values here. You can see the data. Okay, and the mean value. Okay, root mean value, RMSE value that I have calculated. I have got something. Okay, so we will see more in detail about linear regression and all these details when we come up to that session. Okay, in that session, I am going to show you a use case that is related to simple linear regression. Okay. So these are few details that are that we have that is related to k-means clustering. So let us do some recap, okay, and we'll see what we have here. Okay. So what we have learned today, we have seen the k-means clustering. K-means clustering is something, it is a unsupervised learning model. Okay, we are going to do some clustering here. We are going to segmentation. We are going to do segmentation here based on the similarities. Okay, so we start the process. We start the process by initializing number of clusters. When we initialize number of clusters, number of, okay, these many number of centroids will be initialized. Okay, these are randomly given. Okay, when I get 2 different random centroids, automatically it is going, so we are going to measure the distance between each and every data point, and based on the distances I am going to get the clusters. When I get the clusters, I am going to use the Euclidean distance here. Okay. And after getting clusters, based on the database, I am going to take the mean value. Okay. And using this mean value, I am going to get again 2 more centroids here. So my cluster will be moving. Okay. My cluster will be changed. Okay. Whatever initially formed clusters will be changed. Now, based on these new centroids, again I am going to calculate the distances, and this process repeats until a criterion, okay, until a stopping criterion. That means until a point where after that point my centroids will not be moving. Okay, the distance between my centroids will be almost negligible. Okay. Like we can say we are not getting any further mean value. Okay, the same mean value is repeating again and again. A simple example. Okay, so we are going to, until that point we are going to repeat this, and we have to look about the oscillating points also, because there may be some points that are between these clusters, and maybe due to these, so we have to fix some iterations. Okay, so based on that we can rectify this issue. So, what are the limitations that we have seen here? The number of clusters must be chosen upfront. Outliers can have a strong influence on results. Initial centroid positions have a strong influence on results. Okay, and does not cluster well with cluster. Okay, with clusters of varying sizes and densities. Okay, all these points. Okay, these are limited. So tomorrow, okay, on Monday. Okay, on Monday, we are going to look into KNN. Okay, KNN is a unsupervised learning that we have. Okay, so it is related to classification. Okay, so we are going to look into KNN, K nearest neighbor. Okay, uh, and we'll be looking into a use case that is related to oil and gas analytics. Thank you, friends. Thank you for today's session. Okay, let us meet on Monday. Thank you.